Good morning. In the last class, we learned about the conversion of work into heat and heat into work and some necessary conditions needed for the conversion of heat into work and the concept of heat engine, its thermal efficiency, etc. Then what is a heat engine? Heat engine is a machine that undergoes a series of cyclic processes and converts heat into work. For converting heat into work, we need a series of cyclic processes. So we know that what is a cyclic process, because at the end of the process, the system and the surroundings will come back to the initial condition. That is a cyclic process. So for an engine or to convert heat into work, we need a cyclic processes, a series of cyclic processes. And there are three main requirements for the heat engine, that are, there should be a need of a high temperature reservoir, that is known as source, and a low temperature reservoir, that is known as sink, a working substance. In so many cases, air can act as a working substance. So there are mainly two types of heat engines. One is external combustion engine and the other is internal combustion engine. From the name itself, it is clear that combustion is external and here the combustion is internal. So what is the difference? Internal combustion engine, the examples are gasoline engine and diesel engine. These terms are familiar with you. Diesel engine you may be familiar with. Petrol engine you may be familiar with. This is a gasoline engine, actually is a petrol engine. So these terms you are familiar with. So these two are examples for internal combustion engine. There may be another so many examples, but these two are the familiar examples for you. Then what is an internal combustion engine? The gas is confined in a space. The gas in the confined space should rise to a high temperature and pressure in almost all engines. So the working substance should be, or the working substance should have high temperature and pressure at a certain instant. Then only it will convert, then only we can convert the heat into work. That much amount of heat is required. So for almost all heat engines, the gas should be raised to a high temperature and pressure. So in the case of internal combustion engine, the rapid burning of fuel and air takes place confined space called combustion chamber. So in the case of internal combustion engine, the burning of fuel here is, in the case of petrol engine, petrol is the fuel, diesel engine, diesel is the fuel. So fuel and the working substance, air is the working substance here. So fuel and air take place in a confined space, in a particular space called combustion chamber, and raising the temperature and pressure of the system. So in the case of internal combustion engine, we have a certain confined space called combustion chamber. So burning of the fuel and air takes place inside the chamber, and it will automatically raise the temperature and pressure of the system. Then what is, because here the burning takes place inside the chamber or inside the engine itself or inside the chamber itself. So what is an external combustion engine? You may heard about steam engine, Stirling engine. Steam engine is familiar for you. Then in the case of external combustion engine, the increase in temperature and pressure of the gas is accomplished by high temperature surroundings that transfer the heat to the system inside the chamber. So there will not be any burning inside the chamber. the necessary heat that can be transferred from surrounding to the chamber. Here the high temperature surroundings provide the heat to the system inside the chamber. So here the surroundings will be in a high temperature, so heat can transfer from the surroundings to the chamber. So if here usually surroundings are at a high temperature than the system, so heat can travel from the surroundings to the system. So there is no internal combustion, or there is no burning of fuel inside the chamber. That is known as the external combustion engine. So we have internal combustion engine and external combustion engine, and we have to study about the internal combustion engines. That is, we have two examples to study. One is the internal combustion engine example, one is the gasoline engine, and other is the diesel engine. These two engines we have to learn in detail. So the first one is gasoline engine. It is also have a name Otto engine or petrol engine. So in an idealized gasoline engine, here the petrol is used as the fuel, and the cycle of processes performed by an idealized gasoline engine is called an Otto cycle. This Otto cycle, Otto engine is invented by Nicholas Otto in 1876. It contains different processes, and it is mainly having 4 strokes. You heard the 4 strokes that I will detail in the next slides. The concept of 4-stroke engine came from the scientist Frenchman Alphonse in 1862, and an idealized gasoline engine and the Otto cycle was invented by Nicholas Otto in 1876. Based on these 4 strokes, it is working. So the gasoline engine and the Otto cycle, the different processes are invented by Nicholas Otto in 1876. So we can go detailed into the gasoline engine, the working, the properties, etc. everything about the gasoline engine. In an idealized gasoline engine or in an Otto cycle, there are 6 processes. So there are 6 processes for needed vertical motion of the piston known as stroke. So this is a very basic, very simple pictorial representation of the chamber and the valves. So here you can see there are 2 valves, here one and here one, and one is an inlet valve, the other is an outlet valve or exhaust valve. This is actually a spark plug, because we have to, in the case of internal combustion engine, this fuel and the air should be burned inside the chamber. This is the chamber actually, inside the chamber. So to start the burning we need some sparks. So this is a spark plug. It will provide necessary spark to burn the fuel and air inside the chamber. And this is a piston. You can see this is the piston starting, this is the piston, and this is the handle of the piston. In the stroke, actually it is the stroke actually means that motion of the piston, vertical motion of the piston. It may come into the chamber or it can recede from the chamber. So the volume of the chamber can decrease or increase. The volume of the chamber will increase and decrease during the strokes. So motion of the piston, the processes that contain the motion of the piston either inward or outward is known as stroke. So here the system is, what is the system inside the chamber is the gasoline, vapor and air. The gasoline, actually petrol is in the form of vapor and air. This vapor is actually, gasoline vapor is actually needed for the burning processes, and air is actually the working substance. So these together will act as the system here inside the chamber. The working substance is air, which is an ideal gas. So the 6 processes are, we can detail with the 6 processes. The first process is the intake stroke. The second one is the compression stroke. The third one is the combustion. Fourth one power stroke. Fifth one exhaust. Sixth one exhaust stroke. So what is an intake stroke? Intake means initially there will not be any air, any gasoline vapor or air inside the chamber. We have to take it from outside. So what is intake stroke? During the process, it is a stroke, so the piston will move, the volume of the chamber will change. So what is an intake stroke? Gasoline vapor and air which moves into the cylinder due to the suction and receding piston. So if the piston is receding, the air, the fuel and the air, the fuel is in the form of vapor, so it can come into the chamber. Because the pressure inside is 0 initially, then there will be an atmospheric pressure of P0, then that pressure can push. If the valve is open, then the pressure can push the gas and the vapor inside the chamber. Then at the same time the piston can move outside, so the volume of the chamber will increase. That is the intake stroke. The mixture is pushed into the combustion chamber. Intake stroke. The second one is compression stroke. Compression stroke means what? The volume of the chamber will be reduced. How the volume can be reduced? We can move the piston inwardly, then the volume of the chamber will reduce, or it is a compression stroke. Stroke means the movement of the piston either inward or outward. So in the second process, compression stroke, the mixture is compressed until the pressure and temperature rise considerably. So if we are compressing the piston, or if we are compressing the chamber, then the pressure and the temperature of the system will increase until it reaches a certain value. The compression will be there and it will decrease the volume of the combustion chamber. So second one also needed the motion of the piston. The movement of the piston will increase the pressure and temperature of the system, and it will decrease the volume of the chamber. The third one is combustion. Combustion means is actually burning. The burning of the mixture occurs very rapidly after ignition by an electric spark. So you can see there is a spark plug. This is a spark plug here. So this spark plug will start the ignition or burning process. After ignition by an electric spark, the mixture will start burning. Then the combustion products attain very high temperature and pressure. But during this time it is not a stroke, so the volume of the chamber will remains constant. Then it will increase the pressure and temperature of the system to a very large amount, or to very high temperature and pressure. The combustion products attain very high temperature and pressure. Then the fourth one is again a stroke. It is known as the power stroke. Then here the burning products is having a very high temperature and pressure. So during the power stroke, the hot combustion products expands because it is at high temperature and pressure. So it will expands and push the piston away. So because there is a movement of piston, it is known as stroke. So it increase the volume of the chamber. Then while increasing the volume, the pressure will automatically decrease and the temperature also will decreases. The system, during this time, the system performs work on the surroundings. So this is a power stroke. That much stroke will be there. The movement of the piston is very fast, or it is having a high pressure movement or the force of the piston, the outward motion of the piston, the force to the outward motion of the piston is very large. So this is a power stroke, that much power will be there because of the system, the products, combustion products inside the chamber is having high temperature and pressure. It will push the piston outward, and to the piston there will be a shaft attached to the piston. So the sudden and very powerful movement of the piston will cause to start the engine. This is actually the power stroke, and the system during this time, the system doing some work to the surroundings, and during the process the engine will start working. So power stroke, the system performs work on the surroundings. The fifth one, exhaust. The combustion products are there in the chamber. So what we have to do? We have to remove that combustion products. At the end of the power stroke, the combustion products are still at high temperature and pressure than the surroundings. The exhaust valve allows some gas to escape until the pressure drops almost to the atmospheric pressure. So now during the exhaust, the temperature and pressure after the power stroke will be still high or higher than that of the surrounding. So if you are able to open the exhaust valve, then what will happen? The pressure inside is higher than the pressure outside. So the products will go out until the pressure drops to almost to the atmospheric pressure. But during the process, the volume remains a constant. So there is no change in the volume of the chamber, only some quantity of the or some amount of the burning products or combustion products will go out through the exhaust valve. The last process is the exhaust stroke. So there will be remaining of the combustion products after the exhaust. So what we have to do? We have to push the piston inward and completely eliminate the combustion products. Since it is having, in the process occurs because of the movement of the piston inwards, it is again a stroke. So the piston pushes the remaining products out of the cylinder by exerting pressure. So here volume reduced to the initial condition. So then here the one cycle completed. So here we have 4 stroke. One is intake stroke, the other one is compression stroke, then power stroke, then exhaust stroke. And other than the 4 strokes, we have one combustion and the other exhaust. So total 6 processes are there. In the first, we can see that this is an idealized gasoline engine. That is Otto cycle. It is an ideal gas engine. The processes are the cyclic processes are called Otto cycle. It is an idealized gas engine. So we have to impose some conditions, and these conditions provides this gasoline engine as an ideal one. So what are the conditions for this gasoline engine become an idealized gasoline engine or become an Otto cycle? The ideal conditions are, there are 5 conditions, mainly 5 conditions. One is the working substance is all the times air. The second condition is that all processes are quasi-static. The third process is there is no friction or turbulence. The fourth condition is there is no loss of heat through the walls of the combustion chamber. The fifth one is the processes are reversible. Every time it is reversible. It can be taken back to the initial condition itself. So these are the 5 conditions, and by imposing these 5 conditions, we can say that the gasoline engine is an ideal one, and so we can use the concept of Otto cycle here in the case of a gasoline engine. Our next step is, since it is an engine, we have to calculate the thermal efficiency of the engine. What are the parameters? Actually, the efficiency of the engine depends. So, we can calculate all that. For that, we have to move to the work done and the heat intake or the heat transfer between the system and the surroundings, or heat transactions during the processes, and the work done during the processes. And actually, what is thermal efficiency? That thermal efficiency we learned already in the last class. What is the thermal efficiency of an engine? It is actually 1 minus QL by QH. What is QL and QH? QL is the heat rejected by the system to the low temperature reservoir, and QH is the heat taken by the system from the high temperature reservoir. So this is the efficiency. So we had to calculate here the efficiency of an Otto engine or a gasoline engine. So what are the parameters? What the efficiency depending on that, everything we can calculate. So in order to calculate the heat transfer during the processes and the total work done during the processes, we have to calculate, or we have to draw the PV diagram for a gasoline engine or for an Otto cycle. You have to draw the PV diagram for an Otto cycle. So here this is the PV diagram for an Otto cycle. So we can see there are 6 processes: the intake stroke, the compression stroke, the combustion, the power stroke, the exhaust, then finally the exhaust stroke. So we can see that during 2 processes the volume remains constant. What are the processes? During the combustion and during the exhaust, there is no movement of the piston. All the other processes involving the movement of the piston, that are strokes. So in 2 processes there is no change in the volume. There is no motion for the piston. So 2 processes the volume remains constant. So the volume is in the x-axis and the pressure is in the y-axis. So this is the 2 processes where there is no movement of the piston. So this is the constant volume process, that is isochoric process, and this is again isochoric process. So we can start with 5. This is a cyclic process. So if we are starting from 5, after the 6th process the system should be brought back to the position 5. So we can start from 5 to 1, that is the intake stroke. Intake stroke means the pressure is a constant. That pressure is the atmospheric pressure. But during the process, during the intake stroke, the pressure remains constant. That pressure is equal to the pressure of the atmosphere. So 5 to 1 is a constant pressure process or an isobaric process. 5 to 1, it is the intake stroke. The volume of the chamber is increasing. The pressure is that of the atmospheric pressure. Then the 1 to 2, the next process is a compression one. Second one is the compression stroke. Then during the compression stroke, the volume is changing, the pressure is changing, and the temperature is also changing. So it can be treated as an adiabatic process. Compression stroke is an adiabatic process. That is from 1 to 2, it is the compression stroke. From the atmospheric pressure, the pressure may change to some P1 value. The temperature may change from some T1 to T2 value, or the volume may change from some V1 to some V2 value. Then the third process is the combustion. There is no change in the volume. It is an isochoric process. So 2 to 3 is the combustion. During the process, there will be a large amount of heat that will be taken by the system. So, this QH is taken into the system during the combustion process. The 3 to 4 process, the next process is the power stroke. What is a power stroke? The combustion products inside after burning, after combusting, the products are at a high temperature and pressure. So, it will push the piston away out. So, it will increase the volume, then it will decrease the pressure and temperature. But still it is the temperature pressure should be or will be higher than that of the surroundings. The power stroke will reduce the pressure, reduce the temperature, and it will increase the volume. So it will reach from 3 to 4. It is an adiabatic process. So after power stroke, there is an exhaust because the combustion products are going out through the exhaust valve or the outlet valve. So there is no movement of the piston, then the pressure inside is still higher than the atmospheric pressure or the pressure outside. Move from the chamber to outside. So 4 to 1 is an exhaust. There is no movement of the piston. So the volume of the chamber remains constant. It is an isochoric process again. So the final process is exhaust stroke. The piston will move inward and it will eliminate the byproducts or the combustion products completely to the surroundings. So it will reach to the initial condition. So this is the PV diagram for the Otto cycle or idealized gasoline engine. The different processes are, there are 6 processes and these 6 processes are mentioned here. The intake stroke 5 to 1, 1 to 2 is the compression stroke, 2 to 3 is the combustion, 3 to 4 is again the power stroke, 4 to 1 is the exhaust, and 1 to 5 is the exhaust stroke. So this 1 to 2 and 3 to 4 are the adiabatic processes. This 2 to 3 and 4 to 1 is the isochoric process, and 5 to 1 and 1 to 5 are the isobaric processes. There are 2 isochoric, 2 isobaric and 2 adiabatic processes in an Otto cycle. We can calculate the efficiency of a gasoline engine. That we will learn in the next class. Thank you.